Hi everyone. Today we're going to study Z transform of a sum. If A, B, C be any constants and U sub n, V sub n, W sub n be the discrete functions, then the Z transform of the sum A times U sub n plus B times V sub n plus C times W sub n. By definition, we write the summation when n equals 0 up to infinity of the function of this sum, and that is A times U sub n plus B times V sub n plus C times W sub n multiplied by Z raised to negative n. From here, let's multiply the Z raised to negative n to each of the terms of the sum. It becomes like this. By definition of summation, we will distribute the summation to each of the product. From the beginning, we said that the values A, B, and C are constants. So we can move this in front of the summation respectively. From here, we can see that by definition, it is like A times the Z transform of U sub n plus B times Z transform of the quantity V sub n plus C times the Z transform of the function W sub n. This is our working formula. Example 1. Find the Z transform of n plus 1, the quantity is squared. Let us expand the square of n plus 1. So we have this n squared plus 2n plus 1. By the property of Z transform, we will take the Z transform of each term of our trinomial. So we have Z transform of n squared plus Z transform of 2n plus Z transform of 1. In the middle here, we have the Z transform of 2n. 2 here is a constant, so we can move it in front of the Z transform symbol. So it becomes like this. In our previous video, we have the formula for Z transform of 1, Z transform of n, Z transform of n squared. We will substitute the corresponding values respectively. So it becomes like this, and this is the final answer. Example 2. Find Z transform of n minus 2 that is squared. When we expand this n minus 2 with power 2, we have this n squared minus 4n plus 4. Then we take the Z transform of each of the terms. We have this Z transform of n squared minus Z transform of 4n plus Z transform of 4. In our first Z transform, we have a formula for this. In the second Z transform, there is a constant 4, so we can put it in front of this Z. For this Z of 4, we can show that there is a constant 4 and number 1 will be left here. So it becomes like this. A while ago, we have this formula respectively. Then let us substitute the corresponding values. So we have now this Z transform of n squared to be like this minus the constant 4 times the Z transform of n with this value plus the constant 4 with a value of the Z transform of 1. This is the final answer.